So today we're talking about the inequalities, and we have 4 of them. You should remember that the 4 inequalities are these. And this is less than, greater than, and this is less than or equal to, and lastly is greater than or equal to. I always say that these two you can remember that they're the or equal to ones because this bottom line comes from the equal sign. So those are the or equals to. So let's try writing an inequality from a number sentence. So all real numbers x less than or equal to -7. If we break that up, we have all real numbers x is one part, less than or equal to is going to be our sign, and -7 is the number. So when we do this, all real numbers x less than or equal to -7. So s less than or equal to -7. And I know that x is less than -7 because this, the smaller side, so this little side points to the x. So that's less than or equal to -7. All right, let's try another one. So 6 less than a number k is greater than 13. This one sounds a little confusing because we have less than a number is greater than. So let's look at it. And when you look to the side here, remember when we had to write number sentences with subtraction? And we talked about how 6 less than k actually is k minus 6. You have to know what k is before you can know what 6 less than k is. So this we can interpret to mean k minus 6. Well, 6 is less than k means 6 is less than k. So that little is less than, the little word is makes a big difference here. So if we look, if we want to write 6 less than a number k, so there's k, and we need 6 less than that, is greater than 13. That would be how we would write the inequality for this number sentence. All right, what is an inequality that represents the verbal expression all real numbers p greater than or equal to 5? Actually, you go ahead and do these two and we'll check them when we check your notes. How do you determine if a number is a solution to an inequality? A solution of an inequality is any number that makes the inequality true. Any number that makes the inequality true. So, for example, x is less than 5. An answer to that would be anything that's less than 5. So 4 is an answer because 4 is less than 5. How about -5? That's an answer because -5 is less than 5. So it's any number that's less than 5. It's unlimited the numbers that we could come up with. How about greater than or equal to -2? Well, it could be -2 because it says or equal to, or it could be greater than that. So numbers on a number line greater than -2, it could be anything this way, right? So greater than or equal to -2. So -2, 4, 128. Could be any of those numbers. All right, is the number solution? Identify the solution by evaluating, is the number a solution of 2x plus 1 is greater than -3? We are just going to write it like it is an like we did with equations. So we're going to substitute in. So if we put in -3, we want to know if it's a solution. Does it work for x? Plus 1, is that, question mark, greater than -3? Well, -3 times 2 is -6, plus 1, is that greater than -3? -6 plus 1 is -5. Is -5 greater than -3? And again, think about where it is on a number line. Here's 0, here's -3, here's -5. The numbers get smaller as you go to the left, and they get larger as you go to the right. So is -5 greater than -3? No, it's smaller. So is it a solution? Not a solution. Now let's try -1. Same thing, we're going to replace the x with -1. Is that greater than -3? So 2 times -1, -2 plus 1. How is that looking compared to -3? 2 plus -1 is -1. Is that greater than -3? Well, again, on the number line, if you think of it, -1 is further to the right than -3. So yes, it's a solution. You try this one on your own. Put all 3 of those numbers in one at a time for y and see what you get. And then the homework is, we'll talk about the homework tomorrow.